go, here we 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 go.
This is Database Week, 3-day event. We're going to have Malini speaking on databases today. Then we're going to do a 2-hour workshop on EC2 for those who are kind of getting going. Who has just recently signed up to AWS, either this week or last week, and has not used AWS launched an EC2 instance before and done that very well? Yeah, that's very, very well. This very first workshop might be a little low level for you, but know that this workshop today is a prerequisite for the workshop we're going to do tomorrow at lunch as well. So if it seems like you maybe want to skip this one today, realize that you will have to skip the one tomorrow. If you want to do one without the other, kind of come see us and we'll be over here in the corner. So let's talk a little bit about the Loft before. Who's at first? Oh, where's Elsa was in the back. She's not in the back. So we have our Loft manager, our operations manager, and our events manager. Our events manager coordinator currently is out in New York, so you're not going to see her here today. But we have Elsa, who will be out there, and we have Mark, who can take care of you. They'll be at the front desk. If you need any help with things that are Loft related, we're coming here to run the event for you, but there's Elsa over there. Wave, Elsa. Put her on the spot. So Elsa's your Loft manager, and she can help you with any Loft things that we have. Here's the rest of our Loft team. We've got Allie, Kevin, and we've got security at the front desk. It's not James today, but we do have security there at the front desk, so make sure you check in and check out. So we have, in addition to our Loft events that we have here, we have co-working and Ask the Expert. So when we're not hosting an event like this, or even when we are hosting an event like this, we have an entire another space next door to this, just across the hall, called co-working. And you can come in there, enjoy some free coffee, some free drinks, free Wi-Fi. But most important, we have an expert sitting over there at the Ask the Expert bar, and this is usually a solutions architect, a TAM, a ProServe consultant that can help you for about 30 minutes. You know, you can't sit there for 5 hours and get a lot of free consulting help, but you can get about 30 minutes for one or two of your issues that you've got. That and this are some of the best kept secrets here in San Francisco. This is a tremendous value for you to be able to come here for free and get this kind of help. So really take advantage of this, and let's really fill that co-working space next door. When we're done today, if you want, you might have a little time at the co-working space, or if you have a specific question that maybe our helpers can't help you with. I want to bring that up real quick before we get into the presentation for our Ask the Experts, for our presenter today, for my lab assistants and my helpers that we have today here. When they're helping you today, make sure to give them an extra thank you. All of the people that are here presenting have other jobs. Some of them are ProServe consultants, some of them are solution architects, some are TAMs. Myself, this is what I do. This is putting on these type of events is what I do. The Loft staff, they run the Loft. This is what we do. By all means, thank us as well, but we get paid to do this. Our volunteers have a day job, and I can guarantee you when they come here and spend the entire day at the Loft, they will spend the entire night catching up on email, catching up on work that they do in their normal daily lives. So make sure to give them an extra thank you for coming in here and volunteering their time to present at the Loft. There's the password to the Wi-Fi. It's also over there. The restrooms, you're going to go through this door here. If you go through this door on my right, your left, then you're going to get locked out, which is fine. You can go through that door, and then you can re-enter through the Loft entrance over here. 222 # is the code for the restroom, which I think is on the next slide. Yep, 222 is the code for the restroom. Some other events that we have coming up, we've got IoT, we've got Sumerian Day, we've got a Compute Evolve. I will be back here in March for Data Analytics Week, and we're also going to have an ML Days, a 2-day event that we're going to have as well in March. If you haven't signed up for the newsletter from the Loft, see somebody from the Loft to make sure that you're signed up. I think if they register, they're pretty well signed up, aren't they? Is that the case? Maybe not. If you're not getting the Loft emails, then go to the front desk and say, I want my Loft emails, because you'll get an email with all the events that are going on. And again, I can't stress how much of a value this is. Did we give them all codes this morning when they came in for discount codes? Does everyone have a discount code? Raise your hand if you don't have a discount code. Raise your hand if you don't know how to use a discount code. Okay, for those of you who don't know how to use a discount code, go see those people later on when we start the workshop. We're going to start the workshop in about an hour. We're going to fill every seat in here. Okay, we're going to fill all the seats in here. I know there's a few open seats now. If you have your bags or your coats on a seat, please put them down onto the floor so that when we get people streaming in here for the rest of the day, we have room for them to sit. We have some seats on the outside, but we will fill every seat in here. We will have lunch today. It'll be a working lunch right around noon, I think is when lunch is coming in. 11, something like that. We'll announce when it's time to go see lunch. When you see them set up, please don't go grab lunch yet. We will let you know when it's time to go grab lunch, but we will provide lunch for you. Breaks are built in, so it's really kind of up to you to take a break during the workshop. We have an hour lecture, we have a 2-hour workshop, we have an hour lecture, we have a 2-hour workshop. You can take your breaks during the workshops. Exits on both sides. And the biggest question I get, how do I get the slides? Bill, how do I get the slides? Bill, are we going to get the slides? Where are the slides, Bill? I'd like to have, Elsa, do you ever get that question? You will all get the slides, I promise you, if you fill out the survey. Okay, so you will get an email later on today from our wonderful Loft team that says, please fill out the survey, and then once you fill out the survey, you will get a link to the slide decks. If that link doesn't quite work yet, or if that link goes to an empty spot, that's because they haven't had a chance to upload them yet. Usually it's not an issue. But if that is the case and you run into that, go ask our wonderful Loft team, and you will get the slides. Fill out your survey. You'll get the slides. Make sure you gave them the correct email address. That's other stuff on here. I think we're good. That's for another event. So, okay, we're going to take about 2 minutes to switch over to the next PowerPoint and for our first presenter. So, here you go.
Good morning, everyone. How are you guys doing? My name is Malini Saxena. I'm part of the ProServe team with AWS. I've been with AWS for about 3.5 years. I've been in the industry working in data-related technologies for about 20 years. So I'm here to talk to you about what are the different database choices on AWS. It used to be that choices for database was simply a platform choice. You had 1 or 2 platforms you would go choose from, and you'll simply build your entire system around it. So if you had an Oracle preference, you'll build your system around Oracle, and if you have a preference toward Microsoft, you'll build it around that. There were few vendors, really, and this is not, when I started my career, it was just that. 1 or 2 different databases that you choose from, and you go from one to the other, trying to figure out how do you fit your processes to the engine of choice that you have. Today, that's no longer the case, right? We have so many different choices. So the question, when I go to different customers and I ask them, what is your database strategy? Is it still wise that we continue to use the same 1 or 2 choices for every single use case? Or do we have different ways that we can solve the same problem? Do we have to solve everything the same way? The answer is no, you don't have to. But at the same time, we have so many choices now. If you just start looking on browsing on the internet in terms of how many different database choices you have a lot. Some of them are old players, some of them are newer. And the thing is that they all kind of solve different problems. So I'm here to talk to you about what my interpretation of what are this categorization is, what are these different use cases that these databases support, and how can we look at our workload, what is it that we're trying to solve, and then figure out how to build a database strategy. How many of you guys actually are in organizations that have a team that really looks at what their database strategy is? Who have thought about it, right? So you guys have an idea of why it is important. Right? It's no longer the case where you can just put everything inside a single database and start working towards it. You have to know what are the different databases you will have and how would you go about it. At the same time, what you cannot do is have, I was working with a customer where they had, if I'm not wrong, 1,000 different databases built by 400 different developers, all flavors, and no documentation. And to add to the fun, there was ETL going across everywhere, right? How do you take that and scale that? And as people leave, it's all tribal knowledge. Nobody really knows what's going on. So that's really why it's important to have a strategy. It's important to understand what are the use cases we support, and then use the right tool for the right job. Does that make sense? So when I talk to the customers, there are essentially two use cases that come up, right? One is I already have a big investment in an Exadata, in a mainframe even, right? And I want to use some of that investment that I'm using right now, all the money I'm paying to these big vendors, I want to use some of that money to innovate. But in order to do that, I need to go and lift and shift from where I am to the cloud so I can save some money in the process. That's one use case. And the second is an easier one, I guess, which is how do you quickly build new applications in the cloud that are meant for the cloud? The applications in the cloud that second part, I think, is a lot easier to do than the first part. Lifting and shifting what you have today can be tricky. And this is literally what I do on an everyday basis and help customers decide how to do either one of them. So for lift and shifting, it's not easy. Like, it's a very daunting job. And some would make you believe that it's almost impossible because, so for example, up until last year, if you were to try to take a DB2 application and move that, just the database piece of it, move that into the cloud in any other engine, there was no real validated way to do this yourself without having to go through an expensive third-party process. If you were to even do a lift and shift from an Oracle to an Oracle database, even that was hard, just because there can be various, versions that you're worrying about, licensing costs, all that, right? So and the other thing is, if you're trying to go from one engine type to another engine type, so for example, if you really want to go to open source, and you're going to, SQL Server to Aurora, or Oracle to Aurora, the tooling for that was not really there. So part of what we have done is started to build tools and technologies that are verifiable, that we have used in the field, that we can help you, bring your systems up into the cloud easily. That's where Aurora comes in, right? Where we can help in terms of scalability, just trying to do this yourself. If you are trying to go from your on-premise environment to Aurora, Aurora is, I think, one of the fastest growing services in AWS for that one reason, is that people who are coming from these legacy applications and legacy databases, and they want to find a way that, and it has both MySQL and Postgres compatibility. So if you are coming from an Oracle kind of background, PostgreSQL is an easier jump over. And if you're coming from SQL Server, MySQL, or you have a MySQL environment, that's an easier jump. So that's, it's not only it's going to be a good landing place, it also is very scalable, and you will be able to save money. And by the idea of horizontally scaling a database 10, 20 years ago was not there. You would simply always vertically scale something, right? If you need more server power, you add more server to it. The ability to horizontally scale, and horizontally scale on demand now, which is significantly different than where it used to be. So if you have workloads that you have on-premise that you're trying to bring over to the cloud, Aurora is a great place. If you haven't looked at that, you should. And it's, performance and availability of commercial-grade database at 1/10 the cost. But more importantly, it's a very different way of thinking about databases than it used to be. The idea that your storage and your compute don't have to coexist and don't have to be dependent on each other. So if you had a big old system, which you're paying licensing costs by CPU, as you scale in size, you would have to scale in the more number of CPUs and then have to pay more licensing cost. That relationship between the two, CPU and storage, is broken through Aurora. So I think it's a very different way of looking at it. If you guys haven't looked at what that looks like, you should start looking into that. And then Aurora is one of the choices, but we have several other RDS choices. Now, some of those things are easier. So if you're coming from an Oracle background, moving to an Oracle on RDS can be a much, much simpler choice than if you're not ready for a heterogeneous system. And I'll tell you why you wouldn't be, right? If you have a lot of investment, for example, in PL/SQL or codes, or if you have a lot of investment in proprietary systems that have been built into these engines, so you want to keep the engine the same for the time being while you are trying to think through how do you move from one platform to another, RDS can be a really good choice. And what RDS does is basically it takes away the operational aspects. So it's still your database, still your tables, still your data, but it takes away the operational aspects of managing a database on a day-to-day basis, as well as patching, backup, recovery, all of that is taken away. So then you can focus on what your schema is, what your workload is, and how do you make that more efficient for your customer. How do you do the actual migration? Actually, I'm a very big fan of this particular tool. We used to be, to migrate from one place to another, even if it's, if it's heterogeneous, it's super hard anyways. So try to, if you think about, try to compare, and I did this by hand. Try to compare data types in one particular database to data types in another particular database. Like, what's a varchar2 in another database engine? And try to change all of that by hand. That's very hard to do. So there are a couple of tools, a schema conversion tool and database migration tool. Both of them, they manage that. So the schema conversion tool will basically heterogeneously migrate and will tell you what will convert, what will not convert. So that's a very good place to start. If you have a system today that you're not sure how you would move to another engine, SCT is a good place to start, because when you can start to, it will tell you, 80% of your schema will convert as such, 20% you have to do an additional work. Once you have figured out the schema, migrating the data itself, and it's not just a one-time migration, you can do ongoing migration as well. So for example, in several systems, you want to keep your production system up and alive while you're starting up another system. So you want to make sure that it can do a one-time migration, and then from there, it does a CDC-based migration of data. As it comes in, it will move it to AWS. And the good thing about it is it's kind of a decoupled system. So it's going to pick it up, and there is a DMS server that you have in AWS, which is basically observing the changes at your source, and it's going to pick those changes up and then put that changes in whatever destination you have. So the fact that there is a system in the middle, what that does is it makes it easy for you to, for example, use a single DMS instance for several of these migrations. So you can have a single server, have multiple changes coming in, and from that one single server, move that changes to multiple other servers. So if you have one production system and you're trying to make a sandbox, a QA development system, you can literally use a single server to move those changes. If your changes are very, very big, that means your rate of change is very high in terms of just bytes of changes that you have, then what you can do is you can trim it down to, I only want to migrate changes to this one table, and that's all I want to do. That one server will entirely be just doing that one thing. So you can make it as narrow as you want or as wide as you want it to need to be, and it can do your data replication and zero downtime, because your source systems are not even aware of what's happening. The destination system are not even aware. It's just a system that sits in the middle that observes the changes at the source and moves that to the destination. Now let's talk about the new applications in the cloud. I find that to be, most of the modern applications that we are creating now, that are very, very different than your old applications that you've had. So if you think about a ride-sharing app, right, or a social media dating app, the number of users, when you start to build these applications, if you are starting a brand new business of a ride-sharing app, let's say, the expectation is that the number of users can go from 0 to millions in a very short period of time. And then it will vary as the life cycle of that thing goes, right? So maybe at certain points of day, you will have more traffic versus the others, right? So your system needs to scale dynamically. And dynamic, not just by small amounts, right? So you cannot really provision for 0 or 1 million at the same time. You have to scale up, scale down. You also want to make sure that you're only paying for what you're using, right? Otherwise, you're not going to be able to sustain that financially. And you should have millisecond, microsecond latency. Nobody's going to wait for your particular app to respond because you have so many other apps already that you can go by. So these challenges are significantly different than the challenges we talked about earlier, which is you have a legacy system, you want to move on. So the way I see it, there are 7 different categories of databases. Now, this, to me, I think is the most important slide of all the entire slide deck, because it helps you think about, when you're trying to use these databases, what is your particular use case? And the use cases are not, these are just a few of the use cases, but you can think about how you would go about choosing the right use case for your particular application, right? So for some of your applications, the relational could be a really good fit. Or for others, you can go for a key value or a graph database. So we're just going to talk today about what those categories are and why you would choose one versus the other. And then what are your options in AWS if you were to go with any of those choices. So let's talk about 3 primary use cases: relational, key value, and graph. For relational, I'm sure most of you guys are aware, this technology has been out there for, 20 years, more than that. You create tables. And the idea at that time, right, 20 years ago when you were trying to build this, is that you don't want to repeat information, and you want to know that the information that you're getting is consistent. So for example, if you have a database of, here we have doctors, patients, visits, and hospitals, if I'm entering the information about a particular doctor and his or her specialty, if something changes in that, I only want to update that in one place. I don't want to go to 20 different tables and update it. So I don't want to go in every patient table and write it down again, because storage was expensive and processing was very, very expensive. So you don't want to do that. You want to make sure you do it in one place and one place only. And when you're doing that, you want to make sure that you have key relationships enforced. So nobody's dropping a table, nobody is removing a key. You will always find the doctor ID in the patient table to match. Data accuracy and consistency, those were the constraints, right? And for those use cases, it did what it needed to do perfectly, right? So as a developer, if I needed to find out a simple, give me who's the doctor affiliated with a particular hospital, that was not hard to do. It was, number of patients visiting a doctor each week, not hard to do. But after this point, right, how many of you guys have actually seen a SQL query 2-page long? Right? How many of you have actually written it? I have. I have. So, and why? Because we were overloading a system that's already there, just because it is there, to match different use cases, right? So we needed to do that. So let's talk about the key value then, right? What's the key value data? How many of you guys have actually used a key value system at this point of time, right? So what is the use case for that? It's simple key value pair. I think simple is the underlying word here, right? You can have a data structure whatever you want. You don't really need to understand what is the overall schema, if things are fitting in a schema or not. The schema is really fluid here, right? But it's resilient to failure, high throughput, low latency reads and writes. That's what we need as a developer. So if I was to build a gaming system, I need to very quickly get information in and out of the system, and that's why I need a schema. It's a simple put, simple get. All developers are used to it. They understand how that works. And what I want to do, though, is do it at a consistent performance, right? So if I want to get information out about a single status of a single gamer, I could simply pick it up from one of that. If I want all the information about this one gamer, I can pick up that batch. But to just get that information out is much easier than writing a SQL query. Now let's talk about the graph database. How many of you guys have actually used a graph database? It's a relatively new thing. And it's important because relationships are first-class objects in this, right? So in the past, relationships between objects were loosely defined in keys that tables would have. But here, relationships are first-class objects. So you have vertices and edges, right? So you have, for example, a user, an edge which defines the relationship between the two vertices, right? And then basically you are saying all of these relationships. So this is a very small and easy way to think about Bill purchased a product, Amit purchased a product, Kevin purchased a product, Kevin follows sport, and Bill follows sport, right? And a new user comes in, right? New vertex comes in, and now you also know that Sarah follows sport, and she's about to purchase a product. What do? You understand at this point of time, the customers who also follow sports have purchased a certain other product. This is what the use case is really for, understanding the relationships between the different objects and then deducting a result out of that. So for something like that, a simple query will tell you what that is. Now, if you were to try to do that in a relational system, that will be a difficult query. And that's just like 5 vertices. Now imagine Facebook style, right? Or whatever pick your social media of choice, LinkedIn even, right? You have 1,000 connections. They all have different interests, different things that they follow. You wonder how you go on LinkedIn and they say, these people you may know. Sometimes I feel like, how do they know my address book? It feels like that. But this is what they're doing. They're trying to figure out that people I'm connected to may also be connected to. So identify a friend in common and make a recommendation. This is a person that Amit knows and Kevin knows. So then, it's basically going to say, hey, Amit knows Kevin, Amit knows Mary. Maybe Mary and Kevin know each other. And then this is how they grow the graph. So those queries are relatively easy when you're trying to use a graph database. So an example for that, Airbnb. I'm sure all of you have heard about it. Many of you have used it. What I'm really trying to say here is that they use different kind of databases for different use cases, right? For looking for your search history, DynamoDB, NoSQL database. For the session state, Elasticache. And for relational data, where you need a referential integrity, they're using RDS, right? Another customer, I don't know if you guys have heard about it, Duolingo. They have about 80 languages that they are trying to use to teach 300 million total users. And a significant amount of traffic, if you will, on their website, right? 7 billion exercises per month. That's a significant amount of traffic. You cannot solve all the problems of a single website, even though it's a single website. You cannot solve all these problems by a single solution. That is what I'm trying to get at. So use DynamoDB, Aurora, and Elasticache, and they're able to serve their customers for different use cases, different ways. So I'm going to try to venture into a demo. And I'll tell you a little bit about what this demo is first. All of you guys can actually download this. You will have the slides, like I said. The demo is out there on GitHub. You can download it. You can, if you have an AWS account, you can. It's a one-click, deployment. And what it does is it talks about multiple use cases within a website. And this is a retail demo where all you're trying to do is understand how do you use key value, how do you use graph, how do you use in-memory, and what do you use search for. So for example, in this case, we'll be looking at the key value pair for just a shopping cart, looking at different products. We're looking at product recommendation by using Neptune, leaderboard by Elasticache, and product search by Elasticsearch. I'm going to try to see if I can do that. Okay, this is my session expiring, which is fine. Give me a second. Oh, well, this comes in. This is the GitHub repository. And this comes with a huge README that you can do. This is a launch stack button if you wanted to do it. Just so you guys know, I did this last night. It takes about 20 minutes. And this is the architecture that it has. It has a lot of AWS services. If you're unfamiliar with any of those, this actually talks about what those services are being used for. So for example, for the backend, you're using DynamoDB, Elasticsearch, Elasticache, and Neptune. For the interfaces, you're using Lambda API Gateway, and then you have using Cognito for authentication, CloudFront for distribution, and your entire web assets are stored in an S3 bucket. How many of you guys actually launch a website from an S3 bucket? Right? So to me, the first time I learned about that, it was interesting because I never really thought you could launch a website outside of web server. And then it just made a lot of sense when I understood that you could do that. So let's see, once I log in, let's see, I'm here. So here's my S3 bucket. I don't know if you guys can see this well. I'm going to try to make it bigger. Okay. So once you deploy this, you get this S3 bucket, which has all of the, basically all the assets of the website are in there. You launch it. This is what it looks like. And you, here we go. This is not the website. This is what the website looks like right now. It's simply, a page that is being served right out of S3 and CloudFront at this point of time. All these images are being stored in S3 bucket. And the data, all of the data that you're looking at in terms of, these books. If you look at my account, let's go. Absolutely, really good question. What database would that be? Before I type in. No, it's a key value database, right? So in this case, think about it, right? What do you need for this particular data set, right? You need items that look something like this. I don't know if you guys can see this well. I hope now you can. This simply is a question of storing all these values. Will every book have all the possible, things? Maybe, maybe not. Sorry. So if you make a change here, right? So the book name is spaghetti. I'm going to say spaghetti new. It will make a change into the object right there. And if you are a developer trying to store all these key value pairs, it's much easier to do this. It's actually, if you look at it, this is what the JSON looks like. And you make a change. It has a unique identifier, which identifies what this book is. And some of these attributes, which may or may not be available, for example, for a newer book, maybe the rating isn't available, which is fine. You don't have a rigid schema that you need to fit this in, right? So then you simply save that here. So I have my spaghetti as spaghetti new. If I go back, most of these sessions are expired because they were internal. Now, if I look for my book, I just look for the word new. Should come back. This is the new book, right? So I just updated a DynamoDB database to quickly do that. Now, but there's a lot more going on here. Yes, go ahead.
Are you able to process payments and stuff using this architecture?
Yes. So you could just add it to cart, and so if you look at the GitHub repository, I can actually check this out. Here is my credit card number for everybody to see, and I bought it. What it does, though, it's important. It not only it captures what you have bought, it captures how many times a book has been bought. So if you look up there, bestsellers, you keep buying it, and your book will come up in there, because it knows how many times a book has been bought. And that's a different, so think about right now, we're just talking DynamoDB. But something else happened there. It's not just DynamoDB. DynamoDB collected just what the attributes are. DynamoDB does not know anything besides that process. As soon as I made a change to DynamoDB, this change here, and this isn't directly querying that. So what happened here is in DynamoDB, that table that I had, I have a lot of tables, I'm sorry. What it does is it does this. There's a streaming component of DynamoDB table. So if in a typical RDBMS concept, if you think about a trigger, what a trigger does is if you make a change to a table, it publishes that change to whatever it is you're publishing it to. If you create a stream right here, so you simply come in here and create a stream, and then I created a trigger that's writing it, sending it to a Lambda function. And what that Lambda function is doing really, it's going to open it up here. And you're welcome to read all the code. But what it's really trying to do is publish this to my Elasticsearch server. And all of this code is available for you, Elasticsearch server, sorry. So all of this code is available when you do the GitHub repo and you apply that, all of these functions will automatically be made. But what it's trying to do, so what you're essentially doing is you're able to make a change into a table and publish that to the cluster, which publishes it out everywhere, which changes how quickly you can see the change in a system. You don't have to do a lot of things on your own. So that's one part of what we're trying to do, right? So typically you search it over here, this search go to Elasticsearch. Elasticsearch already knows the change that you have been made through Lambda function that's listening to the changes in the DynamoDB table. That's able to take that entire experience. So you have two experiences that we talked about, right? If you the product catalog as well as the search. The other thing that we're talking about here is this, bestsellers. For that, if you think about bestsellers, it's something that changes on the fly. If you have 5 or 6 users, doesn't matter. If you have thousands of users, if you are a really large bookstore that has hundreds and millions of users coming in, that number changes very quickly. Go ahead.
So the managed streams that you just showed a trigger, that changes happening in the is that just available for DynamoDB? Does that apply to Aurora or other?
DynamoDB feature. Yes, that's a specifically. Oh, sorry, repeating the question. The managed stream is a feature. Is that managed stream a feature of DynamoDB, or is it also available in Aurora? It's not. It's a DynamoDB feature directly. But you can publish it to different things. At this point of time, DynamoDB is publishing. If you can publish it to, for example, a Lambda function, you can really update it the other way. You can go back and update an Aurora database from a DynamoDB table at this point, I think. But to listen into a change in Aurora, I don't think that's, at least I'm not aware of what that changes. So this here, as more and more people buy a certain product, right, your best bookseller should really very, very quickly change. So what you need for that is what we are using here. If you look at the architecture, we're using this here, Elasticache for Redis. Why? Because it has features that can do quick sorting. So what I don't want to do is I don't want to write a SQL query that says select star from there where count star, sort by, group by, whatever else, because, it can do the job when you have 100 users. But what you're really doing is, as the number of users go, as the number of purchases grow, that query is going to slow down. And you're going to find yourself in this chase of, hey, I have too many users, I have too much data, I cannot sort it out very quickly. So you want something that sorts it in the cache. And again, what it's also doing is simply going and there's another Lambda function that goes in and updates the cache in Redis. So now Redis knows what to show very, very quickly when it comes down to the bestsellers list. The third thing that it does, or the fourth thing that it does here, is give you recommendations. So if you, I don't have, since I did this yesterday, yeah, go ahead. You can set it up. Yes, so all of those are Redis configurations. You don't, so for example, you don't want it to live for more than X period of time, depending on what your use case is. If it's more than 30 minutes, do you still want to continue to keep it there? Those are configurations that you would do. But that's one thing, right? How quickly do you update the cache when it gets invalidated? That's the process, right? That's what you need to worry about the most. Things will stay in cache for as long as the parameters are, which is the part of the engine, right? So if the engine says, I have this much memory, things will stay in cache that much, great. You have a first in, first out mechanism or whatever. What's important is how do you invalidate that as quickly as things change? Because you want to make sure that your users are getting the right information at all times. So that, I think that gets tricky if you start to do this all by yourself, right? So if you have a trigger that goes in and directly updates it, that makes it much, much easier, right? And, OK, this is where I want your help. So tell me, why would we use a graph database here? It's not a very hard question, though. Why would you use a graph database on a bookstore? Go ahead. Help users, so graph database, if you think about relationships, yeah, go ahead. Recommendation, perfect, right? So I have friends or other people who have choices like me. If I bought a certain book, other people that have choices like me, what have they done? What are the other books they have purchased? And that's the use case for that. So if you go back in here, I think I have a picture of, yeah. This is what that looks like. So if you visualize this, and so I was not able to set up the Graph EXP because I started late. But if you think about it, if you look at the Neptune database, it's already preloaded with information like that, which is, if you look at these blue vertexes, these are things that, these are users. The light blue are the things that they have purchased. And I think the oranges are the context. So, cookbooks versus something else. And it's creating all this graph that tells you where things are connected, and that's based on that, it's able to give you recommendations on, so the way you navigate this is simply start with the vertex and basically say, give me everything that this user has purchased. And then from there, who else has purchased this? And if you think about doing this in a SQL query, you will be writing pages over pages of SQL functions to be able to extract that information, right? And this is simply, if you try to do this in a graph database, it's a 2-line code. And it's interesting because now we have databases. To me, it's exciting because you have databases that are purpose designed for that one thing. So I don't have to reinvent the wheel every time I needed to do that. I don't have to start thinking about what that would be, right? Make sense? Any questions so far before I move on to the ledger databases? No? OK. Yeah, go ahead. So how do you connect Neptune to the architecture that you have built in? It's a database that you have an endpoint to that you will basically use a Lambda function to connect to and talk to that. Yeah. So if you look at all the Lambda functions I have that you build as part of this, right? There's a lot of Lambda functions. This right here tells you what I'm talking about, right? This answers your question, I hope. Everything comes in through the internet, goes through your, S3 bucket is going to provide you the content. CloudFront is going to, show you the content. Cognito is going to give you the authentication. CloudWatch is going to manage your system. API gateway is the front end, obviously. But then everything is connected through a Lambda. Everything. So DynamoDB is writing to streams, which is writing to the Lambda, which is writing to the Elasticsearch, is writing to the Redis. Lambda is writing to the Neptune directly. If you want, we can look at what that Lambda looks like. Go ahead.
Lambda's allowing you to not use a server, right?
Yes. So Lambda, if you guys don't know, is a serverless, way to run your code on the web, right? So if you have a piece of, so you don't have to stand up any server. All you got to do is go in, and so I'll show it to you. I like it.
So if we wanted to connect those databases to an S3 bucket website, we'd have to use Lambda. Is that correct?
Lambda would be the best way to do it. You don't have to do it, but there are ways Lambda is the best way to do it. You don't have to, because if you think about it, all of these are APIs. I mean, these APIs are published for all of these services. There are APIs for DynamoDB. There are APIs for Neptune. They're all published. If you wanted to write a piece of code, run it on your local machine, which we all are used to, we could do that. Right? Lambda is simply a way of doing that in a way to make sure that you don't have to stand it in a server. When you're doing this in a development mode, doesn't matter where you do it. When you try to run it in a way that you can publish it, and then you have all the availability, scalability built into the system, that's when you start to use it. I start my whole thing with the Lambda anyways. Here's the recommendations. You're going to see a lot of code that comes in here. But if you see, what all of these things are libraries that are built in. So it's not just simply a small piece of code. You can import libraries. You can import, things that you would need for your particular piece to run, which is like any other piece of code that you would run. This looks like a large Lambda function. And it tells you, and you can do Lambda layers and all, which we can talk about. But the idea is, it's a piece of code that takes an input, and it can connect to multiple. There's something called Boto, and I use Python. But there's something called Boto that you can use that is the library that gives you all those APIs that you would talk to all the Amazon services. So for example, in the middle of doing your publishing to Neptune, if you decide that you want to write a CloudWatch event, send an alert to somebody. Like, okay, if some product has been ordered too much, right? If you are over-ordered something, you want to run your custom logic somewhere in the middle and say, hey, if I sell more than X number of books from this based on my calculation, send an alert to somebody. Lambda would be the best place to run that. Go ahead, please. It is a function. It's a function very similar to what you would write. And Python isn't the only piece of language you write this in, right? You have a lot of languages you could write this in. Right? And different versions of them as well, as you can see. So whatever is the language of choice really you have, it's a simple place where you just come in, upload your dependencies, all your libraries, and if you run it, you will see, you can define what the tags are, you can define the basic settings of what's your timeout, and you can run it within your VPC. So that's the important part. You can run it securely within your virtual private cloud. Question? Mm-hmm. Yeah, I have used Lambda and EMR. EMR is just another service, right? So any API that's available via Boto for EMR is available to your, well, Boto I say because of Python, but any API that's available for EMR. So for EMR, you would do things like you want to check the status or the health or how big is my cluster, to upsize or downsize the cluster. All of those APIs you can use in your particular Lambda function to do it. Go ahead.
Can you manage the Lambda function code from some external IDE, publish it to GitHub and have it deployed here, or do you have to use this?
So you can, and you have published, they have the code published here. But what they have published really, if you think about, if you look up here, well, I don't know where they have, here we go. So this is the JavaScript code that they have published up here, right? You can publish it here, but to run it, you run it in Lambda. Because to run it, you need a place to run it, right? You need a container where it can initialize all your objects and everything. That's what you do. You don't have to do this, right? Oh yeah, so we have all code deploy, the whole pipelining tool, the DevOps pipelining tool that you can use to deploy that. A lot of users do that. Heavily automate how your code is deployed to serverless, so you don't have to worry about the health of your server. Why would you want to do that? It's because you don't want to worry about the health of your servers as you're trying to run things. So I find the moment Lambda came in, I think it was a couple of years ago, we were all really happy about that one piece of code, because then I don't have to stand up an EC2 instance every time I want to test something out. I can do this in 5 minutes and then make a change, and keeping a Lambda out there doesn't cost you anything. I've got Lambda sitting there for like 2 years ago, and I can go back and pitch into that and say, hey, this is the code I wrote, as opposed to trying to find out that EC2 instance I wrote that piece of code in. It's to me, it's liberating, really. All right. We have 10 minutes left, so I'm going to quickly go over the rest. Let's see if I want to use the slideshow. There we go. What's a ledger database? How many of you guys have actually heard about what a ledger database is? So anybody? Yes. So it's a relatively new concept in terms of, like, nobody's asking for a ledger database by name as such by now, but they all have that requirement, right? And what is the requirement? The requirement is, I want to have a system that's immutable and cryptographically verifiable. It's a big word, so I'll try and explain what that means. When I write something in a database, I want to make sure that nobody has touched it. And I want to not only trust your word for it, I want to verify that cryptographically that it is the case. So for example, if you start thinking about your healthcare system or your government system, your history with your cars, manufacturing, when a record is placed, how do you make sure that nobody has changed that? And how do you have different versions of the same thing, right? So for example, if I bought a car, that car comes, maybe it has a previous owner, maybe it has another owner before that. How do I know that chain, the lineage, is managed and maintained and not played with? How do I have an immutable, cryptographically verifiable system? A hash function, thank you. But can you do this in RDBMS table? In theory, you can. You can do this in blockchain, yes, but if you were to do this in a RDBMS function, you're going to create audit tables. And the problem you're going to get there is what you get in most RDBMSs, which is I may be auditing too much, which is I have this huge trail. So if I have one product table, one table, right, its history of how many times it has changed, if you manage and maintain every record, it can get really huge over a period of time. So maybe you're auditing too much, right? And there are a lot of ways you can make a change to a database. So who says a super user can't go in and make a change? It's impossible to verify that a piece of information as it was built in was kept there, right? So that's one of the problems. Blockchain, yes, you can do, right? Which is some of the customers have this need that they need distributed consensus, right? They want everybody observing a process, coming to a recording that, yes, we saw that happen. But if you're simply trying to create a database, if you're trying to just store a set of values, maybe that's unnecessarily complex. Maybe you don't need to go all the way down there. And also, it's difficult to maintain, how to use, and all you're simply looking at is a simple way to have a completely verifiable, series of events that you can quickly query and that can scale as your number of products grow up, right? So what's the concept, basic concepts? I'm just going to go quickly on this. There's a journal. If you think about the state of a particular record changing over a period of time, that's journal. Each of these little square boxes, they're independent events. And we're going to give an example of how that works. And each of these independent events end up being either a current event or a historical event. So if you start thinking about your credit card statement, right? the amount that it has today, that's the current. What it was 10 days ago, what were the series of events that you got in, right? If you think about it, that should be immutable information. Once that information goes in, even if it's incorrect, it needs to stay there. Even if you made an error, that error needs to stay. And then you need to have a second record that changes that error, but we should not lose the fact that there was an error made, right? So if you start looking at trying to build your own ledger, I really think that thinking about doing this by yourself will be very, very hard to do. So an example, right? Let's say we are trying to build the simple system of DMV, right? We are going in and we have a car that gets registered. Here's my record for that. I'm trying to look for, this is the car that came in. I have one version of it. And that version, which is how the car was registered with GMV, I have a hashing algorithm that caches it, a digest that gets published, and basically with that hashing algorithm and the digest that gets published at the time, we have the record as it stays right now, right? Another user gets this, car, it gets resold, another record comes in, and then it moves from this state to that state. So what is the current state right now? Is the new record. It has made the change of the owner. You record the second event in the history. A third user comes in, you record the third event in the history, and then change that. It's very simple. But important thing to know here is that because it's hashed, any small change, even if it's a mistake, so if you misspell somebody's name and you redo that, that's a separate hash. That's a completely different hash. So you have to record both the states. And at any point of time, if somebody asks me, have you changed that information? You could go back and look at this and say, my hashes match. That means I have not changed the information. Simple as that, right? So that's where the QLDB comes in. If, it's immutable, cryptographically verifiable, very highly scalable, and you can use it as a service. There are no servers to manage that you could, use a fully managed ledger database. I want to quickly go through the last type of database, which is time series data. Time series data is not simply storing a timestamp in a database. It's really a database where over a period of time, you're trying to observe something that happened. So for example, changes in stock prices, changing in, how something gets delivered out of a delivery system. So for example, a package, when it was packed, when it was shipped, time is the basic series, right? So you have to understand that time is the primary single axis of this data model. Everything is being observed over time. So once you have that in your mind, that it's a time series database, which means that everything is being observed over a period of time, you can specialize and optimize that stack very heavily. Now you have specialized functions, for example. So for example, you have IoT sensors, right, that have data that they are observing over a period of time. You will have a lot of basically information. You could do this in a relational database and a timestamp function, but it's going to be very, very hard to manage that because you don't want, especially if you have an IoT system, you don't want to have a rigid schema. You want to have a schema that can change on the fly. You can have missing data points. If you guys have ever managed, the connection breaks, you have missing data points. And then you want to make sure you find a easy way that can interpolate the data that is missing, right? So that's what basically a time series database does, is it can help you fill up data, purge data, things that you would have to do manually by using code, you will be able to manage that using that. So you can use a scalable system. Scalable means that you can tier. So the thing I like about the most is it's serverless. You can have different layers where you can store the data. So as you were talking about earlier, right? For the 30 minutes of data that I need in a time series, I need it immediately. It can be in cache, and then you can send it to a warm and a cold storage later on. So you can have different stages, and you can have the system do this automatically. So you don't have to worry about how the data is flowing across the system, and then you can query it on a time series as you need to. Make sense? All right. So these are a lot of choices, and my hope is that I was able to explain why you would use one versus the other. I'll be here after this if you guys have any other questions. All right? Thank you. Thank you.
Light me up. There we go. All right. Give me a second to change laptops real quick.